All right, everyone. So thank you for being all here today. Today we have Julie Barnum from the Deep Learning Laboratory at the University of Colorado Boulder. And Julie has a wide experience in multidisciplinary research with a bachelor degree in applied physics and a master in atmospheric sciences, and a lot of experience working with several space mission software. Some of her community projects include being the principal investigator for the Python in Heliophysics community at LASP, which she will discuss today. So, Julie, the floor is yours. Thank you very much for being here today.
Hi, thanks for the introduction. All right, so today I was asked to give a presentation about a newer effort that I'm doing that's part of my roles and responsibilities as the PyHC or Python and Heliophysics lead. So I'll be talking with you all about a software search interface for heliophysics and space physics, as well as Rebecca will be then talking about the associated metadata registry and things of that sort. And it's certainly not just Rebecca and I on this. It's a group effort, and just a couple of the other people on it are Catherine and Joe, who are listed in the presenter title. All right. So the Helios Software Search Interface, or the HSSI, the name is kind of being workshopped right now. So why in general is a software search interface needed, for heliophysics? Why won't just a general science-wide approach work? So generic search interfaces like, going to a code repository like GitHub don't have science-specific filters in order to improve search results. So you might be just sitting there sifting through packages for a really long time before you start to find things that might be useful for what you actually want to do within your discipline. And then ADSs, or the astronomy. Oh gosh, I'm blanking on what ADS stands for at the moment. Rebecca, you can jump in if you recall.
Astrophysics Data Service.
Thank you. Thank you, Alice. But yeah, the Astrophysics Data Services interface links to related software based on software citations, but those are not something that are really pushed, at least at the moment, within heliophysics publications. And so while, that works really well in astrophysics, that's not something that necessarily translates well over into heliophysics. And then as to why, the software search interface capabilities that currently exist in heliophysics, aren't sufficient, I can, speak certainly from my background that the PyHC search interface, is limited. We've done a lot of work on it, but right now it only includes like really Python-centric open source software. And even then, the search capabilities within the software are just really focused only, what we have within PyHC. It's not including all Python you might find in heliophysics. Additionally, there's a lack of software in many categories, especially within PyHC. For example, we don't really capture currently AI ML software, modeling software, mission-related codes, that kind of thing. So far, it's really centralized on like data wrangling and analysis and visualization. There's also a need to align with the metadata structure with heliophysics needs and international standards. And then finally, there's a lack of links, to other important resources. For example, related software for a specific science problem you might want to answer, related data sets that would be helpful to use in completing scientific analysis, that kind of thing. So, and then, so funnily enough, NASA has, a software release category, a website, software.nasa.gov. And why isn't that enough? So existing science software that's actually funded by NASA is not totally represented within the release categories that you see here. For example, there's not an AI ML category in there. There's not necessarily general analysis there, post-processing, that kind of thing. It's not linked to the ADS or SciX. It's not linked to important data sets that would be useful within research. And as you can see, if you read through the titles there's not heliophysics specific software mentioned within there. Frankly, other big important science domains within NASA necessarily linked there. You might have to dig through all these various release categories to find what you need. And then finally, there's a lack of community awareness. This particular slide that's up there came from a presentation at last week's Software for the NASA Science Mission Directorate workshop that Rebecca, who's on the call, I'm going to present in a minute, wonderfully organized and made happen. But yeah, this was actually the first time I had heard about software.nasa.gov myself. And I'm funded by NASA, and PyHC has a lot of NASA influence in it. So it needs work for, just being known by the community even. So proposed solution forward, we want to create a heliophysics software search interface for the HSSI. So this helps to answer the open science call in heliophysics so that we can unify all of our software metadata with international recommendations, improve the science software search capabilities, like what I'd mentioned earlier, and then simplify citation of software in our other resources. And what the HSSI would provide is just one landing page that you can go to search for science software, specifically in heliophysics and space physics. Because there's already a nice, collection that's organized within PyHC of all open source Python software in heliophysics. We would start with that just because that's a known, known quantity. And then the goal would be, of course, to then expand out to heliophysics code, in other programming languages. Python is certainly not the only one. There's a lot of IDL, MATLAB usage and so forth within heliophysics. And then we would work to include software, in other categories. As I mentioned, PyHC is really heavily focused on like data wrangling, analysis, visualization. But again, that's certainly not the only thing that exists within software within heliophysics. And then, of course, we'll be creating interoperable software metadata, and Rebecca's going to talk more to that in a moment. So we'd implement a new software metadata structure, tailored for heliophysics software registration, and build a registry of software metadata with a REST API on top of it. And all the information that we'll use, that'll go in to this new HSSI and associated metadata registry will be sourced from input from community meetings, like, the PyHC meeting to start with, since we're starting with those packages. But then, going broader, going to AGU, going to other heliophysics, science-specific meetings, CEDAR, GEM, SHINE. If you know what any of those acronyms mean, no worries if you don't. And so forth, and, various advertising campaigns to try and get the word out there about what we're doing. So we don't intend to completely start from scratch on all of this. We're going to be building upon the designs of other highly functional things. You have at the bottom, there's the PyHC website where you can see we've got, keyword filters that we can kind of start with, the very basics of what metadata do people normally look for when it comes to software and heliophysics, specifically for Python in that case. But up top, there's also the NASA Goddard's Exoplanet Modeling and Analysis Center, or EMAC. They have a really, excellent, well built out page for how you can search for software and related data sets within exoplanet research. And so we'll be working with them in order to create this HSSI. We'll also then be looking to, the ADS, try to improve software.nasa.gov, give back to, what's given to us, as well as, take some inspiration from Zenodo. So now I transfer ownership of presenting over to Rebecca.
Thanks, Julie. Can everyone hear me? Cool.
Yes.
Thumbs up. All right. So software metadata portion. I said before, we want the metadata registry to be hosted on GitHub so that it's open. And then we want a REST API on top of it to help make it interoperable. We also want the metadata model itself to be interoperable via a new instance of OntoPortal that was created by one of our European colleagues for heliophysics, so that we can be better interoperable with other metadata efforts in our field and internationally. Now we're going to start with the current structure for PyHC, also start with the structure that EMAC uses, and we desperately want to align with the international structures such as Code Meta and DataCite and those things. So right now what we're doing is we're doing a very cursory study of these things because we're not funded yet. We're doing an initial study on what controlled vocabularies we need so that we can have nice consistency between our metadata. And we're putting a detailed use case study. We're putting that off until we have some solid funding. Next slide, please. Where we are now. Okay, so what we've been doing is we've been working with EMAC based on their experience and then our experience with PyHC to just get a rough sketch of what we're thinking about here. And that's what the picture is at right. So we have a list of concepts that based on just experience and some really rough use cases, nothing detailed yet, of the concepts that we want to prioritize in a search interface versus the landing page or the information shown in the search results. And then we've done a first pass at aligning those with the code meta properties, and we're hoping to also align those with DataCite and schema.org via the mappings already available, and hopefully that's an easy process. We've already identified a few controlled vocabularies that we're having trouble finding, such as software categories. We got pieces of things from various sources, but nothing that really fits. So we're going to have to find a way forward on that. In Heliophysics, we're going to need a controlled vocabulary of missions and instruments so that we can better connect the software to the things producing the data. And we're hoping this group can help guide us towards these vocabularies and maybe others that are missing. Obviously not the heliophysics specific ones, but others also. We're putting off more detailed studies, including those detailed use cases that need to be done and determining mandatory versus recommended versus optional to come once the study is funded. Next slide, please. I'll steal this one, Julie. So we have an upcoming Dash session. Neither Julie and I are listed on that because we're on the program committee, but our two other colleagues are leading that. It's Joel Renault from EMAC and Catherine Bird from HDRL. HDRL is the Heliophysics Digital Resource Library. That's where I am working from. And the point of that session is to get invited speakers, maybe also someone from this group, so consider that invitation extended, to talk about international efforts on software metadata, ways we can align, those kinds of things. We're also looking in this session to have community input, maybe a part of it to be an actual working session, where we get input from the community and how they want their software searched for, whether it's in Python or not. If you're interested in doing an abstract, that's due August 10th. More likely, you're more interested in maybe, hopefully, attending our session and providing input. And that registration is due September 15th if you're going to go to Europe to attend it in person, or October 7th if you attend online. If you attend online, I think the registration is free or close to it. And we'll close out with Julie summarizing us out.
Yeah, thanks, Rebecca.
Sure.
Okay, so summary of what you just heard. So we're proposing a heliophysics-specific software search interface, the HSSI, that aims to significantly improve, the FAIR principles for research software in heliophysics. There's been a NASA Rosa's high priority open source science proposal submitted to hopefully fund this effort. Although, if we are not awarded that, we're still gonna find other avenues to make this happen. We think it's really important. Initial discussions happening between PyHC, EMAC, and HDRL are ongoing to make this happen and really produce a collaborative effort result. A bare bones framework is now, as Rebecca just outlined, nearly ready for more detailed efforts once there's funding to back that work. We're seeking initial collaborations, with the international science software metadata community to really make this the best product that it can possibly be and to conform with expected standards. And then, like Rebecca just showed you, there's a dedicated session at Dash this fall, hybrid, so either in person in Madrid or online. And I believe that's all we have for you today.
All right, thank you very much. I would like to open the floor for questions. We don't have a lot of time, but we have 3-4 minutes for questions. Who wants to go first? I see Hervé. Please go ahead.
Yeah, one question. Do you have already a curation model that you'd like to go for to to basically maintain all of these metadata? Do you think that all the metadata would be provided by software developers themselves, or that there would be a team of curators taking care of part of this work?
So that's one of the things we've discussed, but just a little bit. One of the things that EMAC is moving forward on is there's so many submissions that it's hard for them to keep up. So the new idea they're pursuing is to have community curators or people that are knowledgeable about software in the field or even wrote some of it themselves, actually contribute maybe 2 to 3 hours per month to help improve metadata records and maybe even suggest new things to add to this metadata. Another thing they're planning on looking into is to do hackathons, virtual hackathons where people that attend are actually paid to attend, and there's an intense effort to either improve some area of the metadata that's significantly lacking, or a push, for instance, to find and create metadata records for, say, AI/ML software in Heliophysics and add that to the registry. Beyond that, we haven't had enough funding to pay for more conversations, but I hope that answers your question.
Yeah, thanks a lot.
All right, Kai.
It's a lot, a good initiative. We tried the same also with a broader community with us, with the OSSR. And I was also asking whether you do the curation, because it's really hard to incentivize people doing a software to go into deep metadata, and especially if you then also use closed vocabularies and that far. So you really need to think about that. But I mean, we had also in the chat an input. I think all the parts that you have listed there as a technology is already available. When you were talking about, for example, the front page, immediately the RSD, the Research Software Directory from the eScience Center, who are also part of our group here, but I don't see Jason today or anyone here, have a platform for actually also which is open source, so you can simply use it. So I think for quite a lot of those things, there are already technical solutions, or SWMAF, for example, there's in the chat, also has a nice solution. But the hard part will really be the metadata. So if you got funding, quite a lot of that will go into a metadata crosswalks, because you were saying it's hopefully easy to get the metadata done. That's always the hardest part.
Noted. Thanks.
All right. So, well, we have reached the top of the hour, and I want to be respectful of everyone's time. I'm sorry, Maxence, but we have to move on. And well, I would like to thank everyone again. We do not have a lot of time to go over any other business, so we'll try to maybe cover them on starting up on the next meeting. And with that, I would like to thank everyone for being here today, and I look forward to seeing you on the next meeting. Thank you.
Thank you.